Get ready for an exciting journey into the origins of one of Earth's coolest creatures, the penguin. In this exploration, we'll dive into the evolutionary story of these flightless wonders, tracing their path from the past to today. Moreover, we will uncover the mysteries of why and how penguins made the incredible shift from the sky to the sea. It's a tale filled with ancient giants, underwater changes, and the toughness of life in our planet's ever-changing landscapes. So let's head right into it. The first chapters of the penguin story unfold around 61 million years ago in what is now New Zealand. Imagine a bird standing about a meter tall, with shorter than usual wings for its hefty body and a slender, long bill. Curiously, it couldn't take to the skies, but it maneuvered itself in the coastal waters during the Paleocene epoch using those short wings. This bird, eventually named Waimanu manaringi by a scientist, holds a special place in our understanding. It's the oldest penguin fossil we found. By studying Waimanu's skeleton, scientists deduce that it was a bird ready for a life in the water, much like modern penguins. However, the mystery lies in what came before Waimanu. How did birds transition from flying to becoming early penguins? The fossils that could provide those answers are yet to be discovered. But modern studies on birds that can both dive and fly offer hints about the journey penguins took from the sky to the sea. The world where those initial penguins lived played a crucial role in shaping them too. Now, let's think about why penguins decided to give up flying. The intrigue lies not just in how it happened, but in why they made such a choice. Waimanu emerged a few million years after the extinction event that wiped out the non-avian dinosaurs and the predatory marine reptiles that once ruled the Mesozoic oceans. By taking to the water, Waimanu achieved something its non-avian dinosaur ancestors never could. It became fully aquatic. Waimanu marked the beginning of a diverse group of diving birds, the ancestors of the penguins we know today. Modern penguins are often thought of as small, formally dressed birds. However, their evolution from a flying ancestor reveals a history where they were giants for millions of years. Some even dressed a bit more casually than the tuxedo-clad image we have today. The key to understanding modern penguins is recognizing their specialization for underwater life. While they still need to molt and breed on land, they've evolved unique features making them dynamic marine predators. For instance, they boast scale-like feathers that keep them warm and dry in cold ocean waters. Additionally, their limbs and heads house structures called retae marubile systems, which help regulate their body temperature. These systems consist of neighboring blood vessels, transferring heat between the warmer arteries and colder veins, ensuring the penguin's core temperature remains stable. Penguins also have stiffer wing joints compared to flying birds, aiding them in both the downstroke and upstroke of their wings. These adaptations make them proficient in navigating the denser medium of water. Penguins' dense bones, quite unlike those of flying birds, further contribute to their underwater prowess. Unlike birds striving to stay airborne, penguins contend with the buoyancy of seawater. These dense bones also play a role in creating a remarkable fossil record for penguins, offering us glimpses into their evolutionary journey. While we're yet to uncover enough fossils to construct the complete penguin family tree, genetic studies suggest that their closest living relatives are winged creatures like albatrosses, petrels, and storm petrels, all capable of flight. The split between these flying relatives and penguins likely occurred between 71 and 66 million years ago, during the late Cretaceous period. Now, let's ponder the intriguing question of why a bird would trade the ability to fly for a lifestyle centered around diving. Flying is undoubtedly energy-intensive, yet it facilitates essential activities like covering long distances and evading predators. The challenge arises in being adept at both flying and diving due to differences in anatomy and biomechanics. A 2013 study comparing energy use in two species of living birds, thick-billed murreys, wing-propelled divers, and pelagic cormorants, foot-propelled divers, shed light on this challenge. The study revealed a trade-off in anatomy. Specialized wings for diving were less suited for efficient flight. Wing-propelled diving requires a large body size, shorter, flatter wings, and denser bones to maximize the efficiency of each dive. However, these features are counterproductive for efficient flight. Hence, there's a clear anatomical trade-off, helping us understand why penguins, with their diving specialization, gradually gave up on the ability to fly. The ecological conditions in which penguins evolved likely played a pivotal role in facilitating this transition. After the extinction event at the end of the Cretaceous, smaller diving predators vanished, creating open ecological niches. The larger marine reptiles and sharks, once threats to diving birds, also disappeared. In this new environment, penguin ancestors with superior diving abilities had an advantage: more food with less energy expenditure. Once they embarked on the path of underwater flight, they rapidly spread across the globe, reaching the places where we find them today. The first chapters of the penguin story unfold around 61 million years ago in what is now New Zealand. By the late Paleocene, they ventured into Antarctica, and by the Middle Eocene, around 42 million years ago, they found their way to South America. From there, true penguins evolved, adapting to their new aquatic lifestyle. Today, the emperor penguin, standing a little over a meter tall and weighing up to 40 kilograms, represents the largest living penguin. However, delving into the past reveals a caste of giants that once roamed the southern continents: Crossvalio, over 1.5 meters tall and weighing nearly twice as much as an emperor penguin, and Kumimanu, standing about 1.7 meters and tipping the scales at just over 100 kilograms, were among these prehistoric giants. These large sizes were a result of penguins no longer having to worry about the constraints of flight and could focus on becoming more efficient divers. Fast forward to the late Eocene, and Antarctica became home to even more giant penguins. Anthropornis, about the size of Kalamanu, and Palaudiptes, towering just over 2 meters and weighing about 115 kilograms, were among these formidable figures. Notably, one giant penguin, Ankeaku, found in what is now Peru, had fossilized feathers with preserved melanosomes, hinting at a different color palette than the black and white we associate with modern penguins. The giants persisted for millions of years, but by about 23 million years ago, most had disappeared, and by 18 million years ago, they were entirely gone. The rise of marine mammals, especially new-toothed whales and pinnipeds like seals and sea lions in the Oligocene epoch, could have contributed to their decline. The giants might have faced competition for food resources, or even been viewed as potential prey. As we shift our gaze to the present, penguins still inhabit the southern continents, from the icy expanses of Antarctica to the warmer Galapagos Islands. Our knowledge of their extinct relatives benefits from the fortuitous preservation of dense bones, coupled with their preference for coastal living. However, despite the strides in paleontology, the elusive fossils capturing the transition from flying to diving remain a missing link in the penguin narrative. The story of why and how penguins forsook the skies for the sea is far from complete, leaving room for future discoveries to unveil the secrets of this evolutionary journey. The tale of penguins is woven into the broader narrative of life's rise and fall on our planet. The extinction of marine reptiles at the end of the Cretaceous era created openings in ecological niches that penguins adeptly filled. Their story echoes the pulse of Earth's history, a history shaped by major extinction events and the adaptive responses of life forms. The rise and fall of giant penguins coincide with dynamic shifts in the Earth's oceans and the emergence of new contenders, such as marine mammals. The extinction of giant penguins, though not fully understood, aligns with the rise of toothed whales and pinnipeds in the Oligocene epoch. The intricate dance of competition and coexistence among these marine creatures shaped the destiny of giant penguins, ultimately leading to their disappearance from the evolutionary stage. As we trace the footsteps of these prehistoric giants, we uncover a world where penguins, far from the smallish, formally dressed flightless birds we know today, once held dominion as significant predators in the Cenozoic oceans for almost 40 million years. The evolution of penguins, marked by their transition from flight to diving, showcases the remarkable ability of life to adapt and thrive amidst the ever-changing landscapes of our planet. The penguins that grace our world today are the proud descendants of an ancient lineage that made the daring leap from the sky to the sea, a journey that continues to captivate our imagination and beckon us to explore the mysteries of our planet's past.